All right. How's it growing, friends? Welcome to Office Hours, your source for free cannabis cultivation education. I'm Kaisha, and I'm co-moderating side by side with my good friend Mandy. Mandy, how you doing over there?
Hey, Keisha, and hey, everyone. We're here for episode 66, also going live over on YouTube. So if you're logging on over there, make sure you send us your questions, and I'll make sure I get those to the team. If you're active on social media, be sure you're following us on all of the platforms. So we're on Instagram, TikTok, YouTube, LinkedIn, and Social Club. But let's not forget why we're here today. We got quite a lot of crop strain questions this week, so let's get right to it. I'll pass it back to you, Keisha.
Thank you, Mandy. All right. So if you're live with us here, you have a question, feel free to type it in the chat at any time. And if your question gets picked, we'll have you either unmute yourself or we can ask for you. Seth, looking very cool in studio over there today. How you doing?
Good. How are you doing today, Keisha?
I'm doing good. The future is bright. I like those shades, my friend. All right. Are you ready for our first question?
Yeah, I think so.
All right, let's do it. We got a couple that we weren't able to get to last week, so let's start with those. Jacob wrote in, have you guys ever tried steering only generative throughout all of flower? And if so, which strains like this type of steer? So that's his first question. Why don't we start with that one? What are your thoughts on that, Seth?
I mean, the first part of it, yeah, I only grew generatively. Probably the first 2 years I was growing. I was growing small plants in a big pot, waiting for it to dry back, being super generative. As far as strains that like that, a lot of your stretchier, your classic OGs, anything super sativa leaning that tends to have big internodes and smaller buds, typically will tend to want to stretch out and throw out looser buds if we start going into a bulking pattern with it. So there are certain strains that I definitely won't really bulk if I want to be able to push the kind of product quality on them that I'm looking for. And in hand, those strains might be the ones that I say, hey, this isn't the most commercially viable strain in my facility, or, alternative solutions like limited drops and saying, okay, we can afford to do 1 10-week run this year. All right, we'll do that and then do a limited drop and get rid of it. But we can't do only 10-week runs because then we lose a significant portion of our product output for the year.
Yeah, lots of opportunity for learning there. Yeah, cool. Okay. Let's get to Jacob's second question. They wrote in, what's the maximum difference you let your runoff get to compared to your inputs for EC and pH when giving plenty of runoff?
Maximum difference in EC, like, are we talking about PPMs going in versus PPMs coming out? And I think that's what he's referring to. A lot of times, I mean, here's a good way to think about it. If your root zone EC is stacked up to 8, that's 4,000 ppm on a ppm 500 scale. So when we're looking at input versus runoff EC, there's a few things that come into play. I mean, number one, if you are irrigating until runoff without utilizing a series of what's referred to as P1 irrigations that are spaced out to prevent channeling, it's going to be hard to tell too much out of that runoff because you haven't achieved necessarily 100% saturation in the media or achieved real field capacity. We're getting runoff before it's had the chance to mix with the existing solution in the pot and homogenize. So if you've got, pockets of the pot that have water in them and the rest is running by without interacting with those pots, we're not actually getting a representative sample. So if I had a 3.0 feed and 8.0 in the root zone and I fed too fast, I might be seeing that runoff coming in way closer to a 3.0 just because it's going through the media so fast and not picking up any salt. If I do it properly, I might see a much higher runoff. But the reality is when we're talking about, putting in a charged solution, it's coming in ionically charged with several different salts, and we're trying to pull out a charged solution. When we're looking at those bulk numbers, it's hard for them to be accurate. We're not so much accurate, but to tell us what to do based just off of those runoff EC numbers. We can start to see when it's getting really, really high. We can see when it's getting really, really low, but we really want to see what's going on in that actual root zone because the equation's unfortunately not as simple as, hey, I put 1,500 in and I got 1,300 out. The plant's reading 200 ppm. At these higher EC values that we're trying to run these days, we're looking at not shifting too hard one way. And mainly what we're looking for in that runoff is pH. So we can actually interpret those numbers and say, hey, I'm building EC, but I'm losing pH. And what is that telling me? Well, I'm getting ions in there, but they're not the ions that I want. So I need to flush that out a little bit.
Amazing. Thank you so much for that, Seth. All right. Jacob had 2 more questions, but we definitely want to prioritize our live folks. So Mandy, I'm going to send it over to you for YouTube questions.
Awesome. Thanks, everyone over there. Andreas has a question about VPD. Hey, you mentioned in some previous episodes a shift in the VPD schedule throughout the flowering phase. I'd always learned to apply a high VPD to start off, a lower VPD during bulking, and then back to a higher one during the ripening phase. Could you explain a little more about the new VPD schedule you talked about? And wouldn't the plant's ability to transpire during bulking be compromised with a higher VPD? Thanks.
So a few things to look at. Number one, if we're talking high, medium, high, what do your incoming plants look like? In a lot of modern systems, we're trying to bring in much smaller plants. Typically, too, when we're stacking media, we're flipping a plant that's, 12 to 20 inches high max. That's pretty small, and that plant only has so much leaf surface area with so many stomata of a certain size to be able to handle that higher VPD. So we actually see during the first 3 weeks of growth with smaller plants, better growth at a lower VPD, but gradually increasing that. So if I came in at a 0.6 at transplant to avoid a little bit of shock, because I'm usually running 0.6 to 0.9 in veg, I can slowly bring that up over the next 3 weeks to about a 1.1. Now, once we get into bulking, we actually want maximum transpiration. So we want to keep that generally between a 1.2 and a 1.4. That's typically where we see maximum stomata opening. They tend to stay open. After you hit 1.5, 1.6 and higher, we typically see those stomata start to close as the plant goes into heat and drought stress. Well, heat stress because it's worried it could go into drought stress if it doesn't do something about it, right? And for ripening, what we're looking at is, specifically to your comment back to the high values, bringing it up into that 1.4 to 1.6 in ripening is usually just a little more insurance that we're not going to get bud rot. And that really comes into play when we're trying to ripen plants, let's say at 75 in the daytime and 65 at nighttime. If I'm at 65 degrees and I go over 60% relative humidity, I know I'm probably going to have mold in that room, unless I've been able to keep that surgically clean and keep my people as hygienic as possible going in and out of there. I'm probably going to have mold at that point. For reference, to keep a reasonable VPD, 1.1, 1.2 at 65 degrees, we're going to need, 43 to 45% relative humidity. Now, if you can't do that, that's kind of where we start to look at running into mold. So really, our VPD is all about optimizing what's right around the leaf surface and making sure we're taking advantage of every hour that the lights are on to have the plant transpire and make sugar and grow.
Thanks for walking us through that, Seth, and thanks for that question. Make sure you keep sending us those questions over on YouTube, but until then, I'll pass it back to you, Kaisha.
Thank you, Mandy. All right. So I'm going to get back to another question here from Jacob. He submitted some really good ones, and I really like this one because I think it speaks to planning, which, growers have to do all the time. So generally speaking, which types of strains like more feed, less feed, medium feed, high EC, medium EC, low EC, and how do you figure it out?
Well, number one, like the rest of ag research, experimentation. So, making sure you have good registration. And luckily, when you're operating in this cyclical facility, you have, your experiments can't be too wild, right? You need to settle on what is a relatively safe production method for you to ensure that you're going to have some kind of crop at the end. If you've got a 30 light grow, hey, it's not huge, but you're not going to switch from cocoa to, aquaponics or aeroponics just on a whim, right? Like that's a big investment. You need to have some guarantees, but the beauty is you're running this system over and over and over and over. If you have 3 rooms, 9+ crops a year to learn from. And really what it comes down to there is, all right, how do I quantify the differences between each of these runs? And then relate that to what are my standards and what do these different strains do under that standard? So in terms of EC, one thing we're going to look at is there are some plants that tend to want more or less EC. A lot of that, though, has to do with that build up in EC. Cannabis plants can adapt to a higher EC environment, We say it on the show all the time. It's called weed for a reason. That doesn't mean it's super easy to grow. That just means, it's easier than orchids. Let's say it's going to tolerate, your humanity a little better. So when we're talking about EC, that plant can adapt. It can build up sugar in the root zone in its roots to offset that osmotic difference. But that's a slow process. Like everything in plants, one day to the next. Can there be a big difference? Yes. Should there be in anything other than vertical growth or new leaves popping early on? No, we shouldn't see a huge day-to-day difference in our external parameters outside the plant. So, some plants have traditionally been grown in lower EC. We see a certain expression. And then without, certain types of technology like root zone sensors, it's really hard to tell whether that plant likes high EC, likes low EC, has an issue pulling up certain nutrients, tends to run into pH issues. There's a lot surrounding that. So, typically we kind of look a little bit at like, some of your stretchier strains tend to prefer lower ECs. Some of your squatter, fatter strains tend to prefer higher ECs. In the real world, we've seen it play out both ways with great results. It's all about managing everything holistically and not having, let's say, some strains, let's say they feed fairly heavily. They cause a pretty big dip in pH as we raise EC. Well, the problem wasn't the EC, it was the irrigation strategy that led to this pH management issue. So if we have a low pH, we're going to be deficient in everything. The difference between a deficiency and a lockout is not something anyone can tell you from a picture. Typically, you need data surrounding that to know something besides just, hey, it has yellow leaves, it has marginal leaf necrosis. Like, okay, cool. That can be a symptom of a lot of other things. I need what's going on in the environment around it to really determine, was it the EC? Because too many times we've seen it played out. Raise or lower your EC a little bit, probably 8 out of 10 times, fix your pH. Usually that's the biggest thing.
So Seth, what I'm hearing in that answer is basically conduct your own experiments, do some pretty thorough crop registration, compare different runs and see apply what you've learned. Yeah. Yeah, absolutely. And start conservatively. When we're talking about running EC, just because someone like myself or anyone out there in this space tells you that, hey, they've had good luck and good times running high EC, that doesn't mean that what that likely means is there's probably a lot that you're not necessarily seeing behind that picture. If I ran high EC and I got good results, great potency, great yield, cool. What else was going on? Because EC is not the only part of that puzzle. Just a difference on the same strain between what it likes under HPS and LED can be huge. So trying to say that one strain is going to perform at a certain EC is not something I put my stamp on, because if it did it that way for you, I can almost guarantee I'll give that same strain to a different grower and they'll add another 5 onto whatever you're running for EC, or even 10. You'll be like, what? That plant can finish between a 10 and a 20 in root zone EC? Like, yeah, it can actually. But if you have that snapshot of that 1 week where it's that high, you missed the very slow buildup early on that allowed the plant to adapt to that. And you're not really getting the full picture. Awesome. Yeah, that was really good. Overview, a reminder of what it is you got to do out there. Y'all are doing some hard work, and the more you can kind of manage your own and track your own experiments and progress, I think the better. All right. I'm going to send it over to you, Mandy. What's happening on YouTube?
Oh my gosh, guess what? We got another question. Chuck wrote in, what would happen if you do the whole run in veg cues versus gen cues? What would be the main differences with the end product? So weight, quality, etc.
So, that's going to be fairly strain dependent. My basic answer is, have you ever tried to grow weed in an aero garden or an aeroponics setup or deep water culture hydroponics? That's where we get to the fact that we can't deprive the plant of irrigations, right? It's in deep water. Typically what we'll see, and it is highly strain dependent, because guess what? Plenty of people have grown plenty of hydroponic cannabis over the years that turned out okay, usually utilizing EC fluctuations and environmental fluctuations to determine ripeness, and then also nutrient content, right? That is part of this. But if you're running super vegetative the whole time, you're going to be pushing that plant to grow longer stems, bigger internodes, and looser buds typically. and strain dependent, more leaf growth. So is it possible? Totally. We got people all over doing exactly that in 6x6x6 rock wool blocks, because they're trying to grow a 4 or 5 foot plant out of a tiny pot. At a certain point, the gas tank isn't big enough to drive the car past the next gas station. So we just got to keep irrigating all day. Yeah, vegetative all the way it's going to be possible, but it's also going to affect certain strains that, are sensitive to, let's say, higher nitrogen inputs. So it's trade-offs, right? Generally speaking, having a bigger pot and being able to go more generative is going to be more forgiving and promote more quality than having a small pot and going only vegetative the whole way.
Awesome. Thank you for that, Seth. And thank you for that question. Until we get more over on YouTube, I will pass it back to you, Kaisha.
Thank you, Mandy. All right. I am on the 4th question from Jacob. Great questions this week, too. What CO2 levels do you recommend through 8 weeks of flowering under mixed LED HPS lighting temps? 75 to 85 VPD, 1 to 1.4 ppfd, 1100 to 1400. What advice do we have for Jacob?
All right, we'll shift those over a little bit. So if we're running 1100 ppfd, I mean, number one, it's good to have a spot checker, make sure your CO2 is on point. Typically, like to run ppfd plus about 250 in ppm of CO2. So if you're at 1100 ppfd, make sure you've got 1350 ppm of CO2. Also, make sure, especially if you're running a mixed light, especially when you LEDs into the mix, you might want some monitoring equipment to make sure you are actually keeping up with your plant's EC needs. A lot of times once we introduce that different spectrum involved with the LED, and it depends on the lights you have, but we see that the plants can actually tolerate and often want more plant nutrients going into them. That's what they need. They're hungry.
Awesome. Yeah. Thank you so much, Seth. And Jacob, wherever you are out there, good luck and keep us posted on what you're up to. All right. We're going to keep it moving. This question also came in last week from Holy Nodes. They write in, what does fertigation channeling mean?
So channeling during fertigation is where we achieve runoff before we've actually hit field capacity. So what's going on is we put water on fast enough that it's moving through the media with enough velocity that it doesn't actually wick around and homogenize with the rest of the nutrient solution in the media. So what's going on is, like I said, it's going down too fast. It's channeling, or tunneling is what some other people call it. But basically, it's going through a smaller, looser portion of the media straight out the bottom. And when we're talking about cocoa and rock wool and these smaller containers, they're actually quite susceptible to that because they're a fairly porous media. And it's easy for that to happen with a big enough shot put on too quickly. So that's part of why, like when we're talking, hey, in P1, different media, we're going to have a little bit different strategy. Part of that's because, like rock wool, for instance, if I start to go above a 10 or 11% shot, I'm probably going to start seeing channeling. And I want to avoid that because I want to hit field capacity and achieve my runoff once the whole substrate has been able to be saturated and had that homogenization occur with everything else, or with the incoming nutrient solution. So that way, if that doesn't happen, if I'm just channeling it through, I'm not going to be able to pick up any of those positively charged ions and push them out of solution and reset that pH balance. And I'm wasting money. I'm throwing it down the drain. So essentially, if you were going to put on 4 P1s or 5 P1s, or let's say 8, and you see runoff before the last one, that could be channeling. That could be a field capacity lower than you thought. If you see runoff each time you irrigate, that means you're putting on too much too fast. And that's the exact visual definition of what channeling is.
That's good to know. Thank you, Seth. Fertigation channeling. All right. Appreciate that overview. You know what a fan I am of overviews. Okay. We're going to keep it moving. Love this write-in from Kane. Kane wrote us. Hey, all. Love the system. Love the page. I'm an old schooler, put my first plants in the ground in 1980 at 13. We mixed fish heads and guts from trout we caught with dirt for fertilizer. Now I'm in 4-inch rock wool cubes, 3 of them on 36-inch slabs, and I have a couple of steering questions. We use Athena. First, in late flush, I end up dropping down into the 30 percentages, sometimes 20 percentages by morning in my drybacks. It comes back with the P1 and the EC drops. Should I just let it go for the 22 hours or give it a 6 p.m., I shut off at 8, maintenance shot to keep it up into the 40s?
The reason we want to keep it into the 40s all the way up until this end is so we can actually apply this steering strategy at the end. So excuse me, I might have to sneeze. Whew, pollen pulling here. But basically, we want to still be able to go generative at the end. So if you are pushing into, like, let's say the 30s, in that last week of ripening, that's not as big of a deal as long as we can carry out a 22-hour dryback without going down to a wilting point and also maintaining enough volume to be able to achieve that dryback. If, let's say, 2 weeks before harvest, you start drying down to 25% repeatedly, we're going to see that field capacity start to topple down from, 60, 65% down to 55, down to 50. And then eventually, if you keep going to the 20s, we'll hit a point where you've got like 35% field capacity. And then we can't really ride that out. So the big thing you want to watch out for is like, hey, I dried in the 20s. What did that do to my field capacity the next day? Did that actually kill it? Did it bring it down? And if so, well, I need to not do that again. And I need to develop an alternative strategy. And then the other thing to look at when you're pushing these deeper drybacks is, watch your EC. If your EC is spiking exponentially in the last hour before watering, like it rises 5 or 6 points, that's probably pushing it to too much of an extreme in terms of our water to salt ratio surrounding the plant roots. So what I would do is start thinking about putting a maintenance shot on if you're going that far. And really, as long as you can keep your irrigation window short in the morning, 1 to 2 hours, as few shots as possible, you can hold off and only put that maintenance shot on 1 to 2 hours before lights off. And you don't need to bring it back up to field capacity and rinse it out, just enough to make sure you're not going to over dry by the time you come in the next morning.
That's a great tip. Okay. Kane goes on to say, second question is similar. In the root in stage, I end up in the same situation. Should I let the EC build and sacrifice some WAC or hit it with a 6 p.m. maintenance shot to keep the WC up and sacrifice a little EC? Appreciate all you do. Please have a great day. Signed, Kane at Brand Candy and Kind Farms Reserve in Maine. Appreciate you for submitting these questions, Kane.
Nice. Yeah. So when we're talking about rooting in, one really important thing to look at is like how much oxygen we're putting into that root zone and how much pore space those roots have to explore. Actually used a great analogy earlier today. If you ever went and tried to farm in a swamp, you go to the mud and you throw dirt on top of the mud and you plant the dirt, go dig down, you'll have plenty of roots in the dirt you threw on top. But when you hit the mud layer, that's like thick clay, you're not going to have any roots. And that's because the pore spaces are tiny and it's almost completely anaerobic in there. So the roots just can't penetrate that media when it's too wet. So when we're talking about rooting in, we want to take, let's say, that first 3 to 7 days typically. And if you're in a 1 or a 2 gallon, even bigger. But what we're looking for is for that media to dry back, at least 15 to 20% of its volumetric water content. And, even up to like 50% of its saturation, depending on what kind of media we're looking at. But we're not necessarily wanting to just sit there and wait for that dryback to happen. What we can do is stimulate the plant by giving it a small micro-irrigation the day of transplant, the day after that, but giving it a very, very small, like less than 1% volumetric water content irrigation. And what that's doing is pushing a little bit of liquid, a little bit of oxygen through the root zone, refreshing it and stimulating that root growth. Because basically the whole thing behind vegetative growth in general is we are stimulating the roots. And that's what's stimulating the rest of the plant. If we want to push rooting, we need to push a little bit of that vegetative style irrigation. We just have to do it on a micro level so that we're not overwatering, oversaturating the media, and not allowing those roots to, basically fill out that entire pot.
Awesome. And then Kane, I know last week we did cover root in strategy as well. So check out that latest episode 65, but appreciate your questions. Thank you for those. Mandy, sending it over to you.
Yeah, thanks everyone for your questions. Burn Tires, Burn Trees wrote in this week. They want to know what causes some plants to have lowered water content, but the EC stays flat. What's the best way to fix this situation? I always thought because they dry back, the EC would naturally rise.
So when we're looking at a fairly low EC situation, a lot of times what we'll start to see is let's just, I guess, set the situation here. If you were riding at let's say an average of 2.5 to 4 EC in your root zone, we're watering in at a 3.0, but every day we can never get it to go much above that 3.0. In fact, it starts to come down lower than it. It almost goes parallel with our water content line during dry down or dryback. Sorry. Basically what that means is if you put, we'll go back to PPMs here, but if we put a 3.0 feed, 1500 PPM on the plant, and that washed our EC up to, let's say, a 3.2 in the pot, but then the next morning we're coming back in at a 2.1. Well, that plant uptook that 500 ppm, 600 ppm there. So basically we'll hit a point where we're almost not putting on enough nutrients to keep up with the needs of the plant. And usually that's what we're seeing there now. In terms of plant health visually, a lot of times that doesn't look that bad. The only thing is we're not really using that tool that is osmotic stress to apply a little bit of osmotic stress to the root zone and push that generative growth. A good way to put it is if we were growing tomatoes or blueberries, I might be a lot more stoked to see that EC line actually stay flat or curve down, because that means I'm not draining as much fertilizer to waste. So for cannabis growers, we want to see that inverse reaction. And a lot of times that just means stacking up that EC earlier on, nailing that stack. And it's going to be tough for some strains, but usually that's where I see that is in that lower EC condition.
Awesome. Thanks for that, Seth. We're getting quite the amount of questions over on YouTube, so I'm going to keep going. Chuck wants to know, I'm curious, let's say your target dryback is 25%. What would happen if you get to the 25% dryback and keep it at 25% by doing small shots, and then for the last shot will be the larger to maintain the target dryback? So never reaching fill capacity other than the initial watering after the root in process. Let me know if you want us to ask him some follow-up questions on the other side.
Basically what happens there is you're running essentially very vegetatively. When we're talking about generative or vegetative, the size of the shot we're using has more to do with working with the media, and right back to that channeling issue. If we wanted to be super generative, we'd put on a 25% shot on our 25% dryback, or 26%, but we'd put on a big shot. Well, we can't do that because we get channeling, right? So effectively, we have to sacrifice some of our super generative push just to properly hydrate the media and maintain pH. Now, if we're looking at saying, hey, we're going up, then we're bringing it down to 25 and holding it. Anytime I'm holding it, I'm actually applying more and more irrigations, which is pushing it more and more vegetative. So the important thing to remember when we're talking about crop steering, especially in soilless mixes, now this changes a little bit when we get into actual soil composition outside of the indoor and greenhouse environments. But typically, at 20 to 50, 60, 70%, we're looking at really similar or negligible difference in matrix potential in the media. So the plant really could care less whether your cocoa or rock wool is 25%, 50%, 60%. It doesn't know. Holding at that moisture content level doesn't matter. What we're looking at is how long have we gone between irrigations? Are we using our irrigation strategy to maintain our pH and also to have our desired EC swings? So what you're playing with is interesting, but if you're doing that after transplant, you're just basically pushing it more vegetative all the way through.
These are good things to know. Thank you for that, Seth. Ed wants to know, when applying irrigation shots, say 100 milliliters, how long should it take for the drippers to deliver this to the block? Is there a recommended flow rate to avoid channeling?
It depends on the drippers, right? We've got 0.3 gallon, 0.5 gallon, 1 gallon, 2 gallon per hour. Those are kind of our standard flow rates. That being said, of all the irrigation systems I've seen, a lot of them don't perform with the calculation you'd think they would once you have the length of your pipe diameter, your pump power, all in proportion, and then how many individual emitters is that one pump driving at a time. So 100 milliliters should not take very much time at all. Basically, you should be able to get that in a minute and a half, no problem. on a pretty low pressure system. But that's why, right back to general registration and quantification, a really good habit is between each run on the same system that you're using. Number one, we want to be taking care of that irrigation system. You want to keep it clean. You want to do all you can. And then especially between runs, you're going to do a super deep clean. But right after that deep clean, a really great habit is to go ahead, fill up your reservoir or turn your pipes on, and even just pump water through. If you have decent salts, they should pump through just fine. If you've got some chunkier stuff, maybe not as well, but go throw 10 or 20 cups out and actually get your flow rate. Turn that system on for a minute and see what you've got, because no matter what spec parts you're using, unless you sat down and very perfectly designed this or had someone do it for you, your flow rate's going to be a fairly unique calibration to your system. And that calibration is also going to change every run because, there's two factors at play here. One, we're pushing salt water, which is naturally a little bit corrosive to some of the plastics we're using in there. And then number two, once those plug even the littlest bit, and some of them don't plug, you can have a plug, you can have them break in a way where they flow completely open almost. But either way, once we've got, more than about 10% outside of or 10% difference between each cup in there, now we're going, okay, I can't accurately put on a single shot of water to any plant because I know that these are all just separate enough that it's going to cause my lines on the graph, if I had a meter on every plant, to start to diverge by 5 or 10% here or there. And that's what you really want to balance is, there's in terms of how fast is too fast, going over a gallon per hour is starting to get pretty fast, but it really, really has to do with how well, calibrated your individual system is. And if you want a good representation, like with cocoa, 10, 12% is usually where we start to see it, but that's heavily brand dependent, depending on the chop size of the different chop size of the husk in there. And then with rock wool, 10% is usually about where we see runoff. And that 10% can be 5-minute shot, 10-minute shot, just depends on what size your emitters are and what size your media is. If I have a 3.5 gallon pot, 10% of that is a lot more than in a 1 gallon pot.
Awesome. I love talking about irrigation, and that's a great question. Keep them coming, guys. I'm going to keep going down our list. Hector wants to know, and bear with me, you guys, he's got a lot of information, so I might trip over myself. I'm currently in week 4 of 10 in flower. I'm having trouble stacking EC with veg steering, and my substrate will not get above 0.55 ms of CM. They're 1 hour away from lights on and at the 0.14 ms CM. Temps are at 77 degrees, 55 RH percent, KPI on average 1.3, no moisture meter at the moment. PPFT is about 800 to 900 PPFT. Any suggestions? And I'm going to chat this to you, Seth.
Yeah. Let me see.
Thank you.
Read it closer here.
That was hardcore crop steering right there. Thank you.
What meter are you using? Usually we're looking at decisiemens per meter. Typically, though, if you're looking in your runoff for this would indicate to me that you're running a fairly low, a couple things. You probably got a low EC feed in the 2.4 or less range, probably 2.0 or less. You've got a high amount of runoff going on. So what I see a lot in this kind of situation is, and this is really hard without, root zone, water content and EC data. But what I see a lot when people try to push vegetative steering is basically there's kind of two things. Number one, we'll either be seeing a really, really big P1 irrigation followed by big P2 irrigations, just a standard set irrigation all across the day. And then the other one that I'll run into is we do have a structured, P1 and P2 irrigation setup, but we're not waiting long enough at the end of P1 to dry down before hitting P2. And that's pushing a bunch of plants across the table to start to run off. So if we hit field capacity 6 times in a day and run off 6 times at field capacity, we're going to just be rinsing that EC down and down and down. I mean, you'll hit a point where the best you could do is rinse it back up to, like if you're feeding at a 2.0, rinse it from that 0.55 back up. But, personally, I wouldn't try to cut runoff too much. I would just try to really organize that into a P1, P2 strategy where I'm trying not to achieve runoff more than once a day. That sounds like it's your biggest enemy right now.
Awesome. Good considerations to keep in mind. Chuck also has another question. Is there of the quality if you do 9 plants a light versus 2, for example? Will a young plant be different than an older one? What do you think, Seth?
Yeah, I mean, so number one, if we're talking about efficiency, we're going to be working with smaller plants, right? We're not wasting as much time in veg, wasting light and nutrients that we're paying for. As far as quality goes, the biggest thing I've noticed is how, number one, we got plant to pot size ratio. If we got a plant that's too big for the pot, it's really difficult to push any kind of generative strategy to try to promote that flower production and quality. Some even genetics that do good under vegetative strategies, if you push it too far, you're going to end up with a lower quality plant. Now, going all the way back to like 2 plants per light, I think we're hitting a point where it's kind of inefficient. Personally, I like to run in the 9 to 12 plants per light range. I've certainly run less in the past, but I find my quality is geared a lot more towards how I treat the plant, not how big the plant's going to get, if that makes sense. Like I personally, I've had great, like if you're a home grower, it's really hard to beat a 3.5 gallon pot and, 2 to 4 plants per light, let them get kind of big, but it's easy. You're going to be able to pull it off with relative ease. Getting into, more like 9 or 12 plants a light, yeah, it might be a little more management, but again, it's all also relative. By the time you grow 2 plants per light, you've probably also done a lot of pruning and plant care on those 2 plants. By the time you've got them 4 months, 5 months, 6 months into a life cycle, depending on how long you veg those suckers before you flipped them and how big the pot is.
Awesome.
So,
thanks, Seth. Okay. And thanks for those questions. Keep going. No, sorry.
Oh, I was just going to say, so I'd like to sum it up. No, I don't see a quality difference there. In fact, a lot of times I see better performance out of the younger plants because they haven't had the time to accumulate any root disease, viral load, or any other problems that associate from keeping an annual plant alive for longer than it would be naturally.
Awesome. Everyone write that down. I know I am. These are great questions coming from everyone. So thank you for that. I'm going to pass it back to Kaisha for some of our Instagram questions.
Thank you, Mandy. Yeah, for sure. So many good questions coming through and a great conversation today, Seth. Really holding it down. All right. Gino Good wrote in a couple of questions. Let's start with the first one. Hey there. Love listening to the advice shared in office hours. We appreciate you, Gino Good. I wanted to ask a question regarding lighting, if that's something y'all would like to comment on. When switching from DE/HBS to LED with increased PPFD, can you recommend a good dimming protocol for early flower through the stretch/bulking period? Flip at around 50%, 350 UMOL, and after stretch plant height, lights can be 900 to 1100 UMOL at 100%. Does that make sense?
Yeah.
There's a lot of abbreviation.
Yeah, no. So yeah, I mean, number one, we're basing all this off of micromoles. Obviously, you already understand that, and it sounds like you have a light meter. So, that's the big hurdle out of the way, right? So yeah, 50% gives you 350. That can be a good place to come in and flower. It depends on what your veg situation was like. Now, a lot of veg rooms I've seen, they range, right? We've got some really old school ones that still rock 315 watt metal halides. We got 1,000 watt double enders in there. We've got some that are rocking LEDs. The big thing is we need to quantify how much light you're putting on the plant before you make that flip. So in an ideal world, we're going to look at DLI, which is, the total sum of all the light energy coming into the plant for that day. We want to match DLI in veg and flower. And if we have good plant health coming out of veg, what that often actually looks like is getting it, ideal world, being able to get your veg PPFD up above 500. And so it depends on how long of a veg you have, if you're able to do that. But if we're matching PPFD, since there's actually 18 hours of lights on in veg and 12 hours of lights on in flower to get the same total sum of photons going on there, we're actually going to crank up that intensity. And this is going to sound a little wild, but if you can really nail that veg, you can be coming in at a 500, 550 and really hit the ground running at 650, 700, no problem in your flower room. If the plants are coming in and it seems like you've got to turn that down, there's a few things to look at. If you're flipping them really small, that's definitely a consideration, just because even though you might have a 0.6 to 0.9 VPD in that room, if you've got some HIDs on those at all, they can get pretty hot. Or flip side, they're really far away from your LEDs. They're getting a little too cold way down in there and they can't handle that. So it's kind of situational. If 350 is where you're coming in, typically you can bump that up fairly quick. Within about a week and a half, you should be able to be at 900 to 1100 ppfd. That is assuming that your EC is in check, you don't have plants that are deficient, and you have enough CO2 for your plants to utilize that higher ppfd.
Awesome, Seth. Thank you so much. All right. I got another question here from Gino Good. Should we refrain from increasing the intensity percentage until after stretch, during a specific week, cultivar dependent? Increasing too bright too soon shows very minor light burn, some chlorosis, no necrosis. Just looking for a guideline that I can implement and continue reading the plant to fine tune. Thank you for any advice you can offer.
Absolutely. I mean, I know I'm kind of answering this very generally. Like I'll pull them up about 5% every day if I'm coming in pretty low. But the real ideal thing is getting those plants hardened off to those high light levels, because when we've got a flower room, we're looking at, a production room, right? We want those plants able to produce, if they're in their 63 days or 57 or 58 days, 56 days, each one of those days is more than 1% of that plant's production life cycle in that room, right? So anytime that we're not able to take advantage of the full inputs that the room's capable of putting down, we're actually not making as much money per square foot per day as what we want to make. So ideally, we want to have them coming in out of veg rocking. In your situation, I would probably start to really try to dial in my veg lights. And because that's one thing I find is a lot of situations we're looking at 300 to 400 ppfd across the whole veg, and that's it. Depending on your system, some people will move plants across the veg room, they'll lower lights, or they'll just increase that intensity if they have one crop in their vegging at a time, really trying to raise that up. So slowly, like I said, 5% every day is probably plenty. But if they're not surviving that flip time, I would really be looking into how they're coming out of veg. And then also another one is, sometimes we come into flower with a little bit high VPD compared to what those plants can handle. So some plants, they might be able to take a little bit more of that light at 0.9 VPD compared to 1.2. So that's all food for thought.
What was that you said, Seth? You want your plants rocking when they're coming out of veg?
Yeah, exactly.
I like that.
Yeah,
you future t-shirt. We'll see. All right. Rounding out the hour, y'all. So if you're on with us live and you want to get your question answered, now is the time. Be sure you drop it in the chat. With that, let me send it over to you, Mandy.
Awesome. Seth dropping the knowledge today. Thank you for all these great answers, and thank everyone for your questions. We're going to keep going to these YouTube ones that we just got in. Kenny wants to know, what's the best way to avoid flushing EC while doing weekly preventative root drenches?
Cleaning. Lots and lots of cleaning in your facility so you don't have to do root drenches. And, the other thing to look at too, what are you doing root drenches for? If you're doing them for fungus gnats, those fungus gnats don't eat your roots. They eat fungus growing around your roots. Why is that fungus there? Are you putting compost teas on and now you're chasing your tail? You're feeding the flies and then also trying to kill them on the back end. So, I mean, that's kind of my answer. Weekly preventative flushes are a Band-Aid for a different problem. So like when I've used those in the past, there were two things present. Number one was an IPM manager who failed to understand that those drenches were more impactful than the fungus gnats themselves on the plants. Number two, didn't think about how much money that was. And then number three, we're putting on compost teas. So basically that drench was a Band-Aid and we're using compost teas in it. There are other issues with that, like our irrigation system plugging up when people want to do that. But basically we're using things in the wrong setting in the wrong order. Compost teas can be great, especially when used in the right setting. If we're looking at a situation where we are totally monitoring that environment and we want control of every bug in it, Well, if I pasteurize my compost, it's not going to be active the way I want my compost to be. So I can't, if that compost comes in contaminated at all, number one, if I get bug eggs in, I got bug eggs in. I'm not going to cook them out because that just makes some really expensive dead compost. That's not very good. And then, yeah, like I said, looking at like what is the Band-Aid? If you're looking at root aphids, okay, where is the reservoir in your facility? You know, are we looking at a situation where we have the moms in our clone or veg room? Do we have some kind of element where we can't actually clean out a room and do a full clean? Does the facility have organic matter around in places that we don't want it, that they could survive? You know, corners, cracks in the floor, things like that. Yeah, I really don't do the root drenches at all, unless it's, again, a Band-Aid. So try to find the root cause of where those bugs are coming from. And actually, if you're listening right now, it'd be great if you could tell me what you're trying to prevent, because root aphids and fungus gnats, that's a different level of severity too.
We love talking about IPM, even though it's a terrible thing to have to deal with. Thank you, Seth, for that. We want to get quickly to our poll that we posed over on YouTube. So we wanted to know, growers, what's your biggest challenge going into this summer? And we wanted to know if it was keeping up with your yields that you needed to produce, keeping up with quality and consistency, or keeping costs down. And yield got 0%, quality and consistency got 78%, and keeping costs down was 22%. Very interesting. Thank you guys for sharing. We are still getting questions, so I'm going to go through those. GL Clarity Films wants to know, if I run a raised bed instead of a pot only, but put 16 gallons of cocoa in, would that still be able to crop steer? Furthermore, if I added another 16 gallons of perlite, would that still work?
Couple things to address there. So number one, whether you're planting in the ground in a pot or anything, if you're irrigating, you're always steering your crop. Whether or not that's intentional is a whole different conversation. When we're talking about beds, we're going to be looking at like, okay, what kind of a dryback is achievable in that bed? Because a bed is still essentially a pot. It's raised up. Gravity is going to pull water out of that bed down into the ground below. The reality is, okay, what kind of sensor do we need to measure that? Now we can look at volumetric water content. We can look at soil moisture potential, soil matrix potential. Any of these are going to give us a good idea of what we're doing, but in the end, we need to look at plant to pot size. So if you're trying to steer more generatively, that's going to be, completely intuitive in those beds, because you're going to water and you're going to wait because you have a decent volume of substrate there compared to your plant size. So really, if we're talking about like what kind of crop steering performance can I get out of this bed? How big of a plant am I putting into that bed, and how many of them? Are we coming out to a point where each plant's got 3 gallons of soil roughly? Because if so, sure. Are we looking at each plant's going to have 10 or 15? Well, then you're only going to be able to go pretty generative in that. And if we are talking about a bed, I mean, if we're going to the point, especially if it's outdoors, in moving in, all these gallons of cocoa, by the time you throw perlite on there, all that perlite's doing is opening up pore space and making it so you can't overwater the plant quite as easily. Can't harbor bacterial infection in the root zone because we're not letting it go anaerobic. If I'm bringing in cocoa and perlite to accomplish that, and then also throwing nutrients on top of it, now in these raised beds, especially if it's outside, we're starting to hit the point where we look back at more traditional agriculture and actually building soil beds and not necessarily going hydroponic with it. You might use some salt fertilizer supplementation, but at that point we're looking at, okay, we are going to be steering generative in these beds because that's all we can do unless we get that plant to pot size ratio correct, which if I've got a 15 gallon bed or a 30 gallon bed, that's a pretty big plant to get a similar ratio to, my 4.5 to 5.5 foot tall plant on a slab. So is it possible to steer that? Yes, but you're going to be always steering for quality, and that's why we still do see, even to this day, like pretty decent outdoor bud coming from like Northern California, other places where, hey, that's what they're doing. in the ground in these big beds. They go give it one big watering a day, you know. As a cultivator, yeah, there's things you're out there doing, but you walking around every day and popping leaves off as you water the plants isn't doing it. It's the fact that you're watering these plants and patiently waiting to water them again, which is what the plant needs to really drive that floral production, terp production, cannabinoid production, and you know, improve and increase quality. So go for it. Just know that you're not going to be able to bulk very well.
Awesome. Thank you, Seth, for that. Going back to Kenny's question about IPM. So he says their sister facility has root aphids. They're just trying to prevent contamination and cross-contamination.
Well, then it's going to be not optimal for a while. You know, if you're going to do a mechanical flush to try to get rid of bugs, you're probably going to flush out some EC. One thing you can do, though, depending on what you're putting in there, I mean, yeah, I guess it partially depends on what product you're putting on. One thing I've used to combat that in the past is actually mixing that in with a pH nutrient solution. So like if I had some natural that I was dumping on or WP22, number one, do not put either of those products through your irrigation system. They're a wettable powder. That's not good. It'll plug it right up. You can do it a few times. I'll tell you that, but not too many times. But usually what I'll do is mix up a separate reservoir that'll go through and hand apply, like with a small sump pump or something, right onto the media, a nutrient solution set at my 3.0 or 3.5 or 4.0, wherever is close to where I'm at right then. That way, when I'm mechanically flushing, I'm flushing back to where I'm going to be. And if you're having to do these, we'll just call them IPM maintenance flushes, and I get where you're at. If you are solving the problem and you're just trying to ride out these few harvests, just got to get them out of the facility. You're not going to totally trash and nuke out the facility just because you got root aphids. You're going to be running a little bit lower EC strategy. You know, my recommendation would be to stay in that 3 to 5 range roughly, so that anytime you're doing that flush, you can go back and hit it with a 3.0 solution. And the worst you're doing is flushing it back to your baseline or up to your baseline. It's really when we start playing with that, like 5 baseline to 11 on the upswing or plus, that's when we're hitting the danger, flushing it all completely out of the root zone. If we keep it manageable, I mean, a good way to make you feel better about it is go on the forums and look back about 10 years into some of the early cocoa perlite growing techs. I remember one of my favorite ones was to mix up like a 5 gallon or a tote of nutrient solution. And you just dunk each pot in until it stops bubbling and then pull it out. And basically the theory behind that was like, hey, we mix up a 1500 ppm solution, even up to a 2000. But with this incredibly wasteful method, we are giving ourselves the freedom to reset that EC and pH pretty much every day and have really good control over it. So you have options. Running high EC while you're doing those flushes is just probably not one of them.
Awesome. Thanks for that advice. And thank you, Kenny, for your questions. Our prayers are with you, and we know you can do it. So, yeah. And yeah, we have more questions, so I'm going to keep going. We have a couple more minutes left in the show. Chuck wants to know, I've heard the quality of plants go down if you have a mother plant for over a year or so. Is that really true?
Yeah. I mean, basically, if you think about it, we've got a plant that has spent millions of years evolving to go to seed and regrow every single year. If you take a plant and keep it in that vegetative state for a long time, there's a few things we're looking at. Real long term, we're looking at, bud sports and somatic mutations, individual branches that pop up that are slightly different, just like apples or potatoes. But the other problem we really run into, and this actually goes right back to the last question, because I can almost guarantee that somehow they either had root aphids introduced and they got into their moms, or they brought a mom in with a root aphid. But basically, the longer you have a plant like that, especially an annual one, in a pot, sitting in a room, I mean, number one, if you really wanted to keep them that long for a year, I hope you're repotting it and treating it like a bonsai tree. But number two, cannabis doesn't have like woody roots. We get disease accumulation in the plant and in the media. So over time, even if it's not your root aphids, if it's Pythium, Fusarium, little bits of Aspergillus, like all these things can conspire to come together and slowly degrade the health of your mom. And moms that are in poor health produce clones that don't root as good, don't grow as fast. And if it's viral accumulation, not just hops latent, by the way, there's several other viruses that can cause strange growth. So some of the best success I actually see is where people have the ability to access tissue culture labs. That's huge. That being said, that has its own risks. We've seen companies suffer contamination and lose plenty of product, but having a, for lack of a better word, offsite repository for your genetics is pretty huge in case you have to clean everything up there. And then being able to essentially crop your moms. So instead of looking at how long can we keep this mom to produce clones for us, it's what's the minimum amount of time I need to grow this mom to get the number of cuts that I need for that next round. And then building your mom cropping strategy off that. Like, okay, I need 10 moms of this strain to make my cuts for that next run. How long does that take? Oh, 2 months. Okay, 2 months ahead of when I need those cuts, I'm starting that mom crop. And that turns into a whole mom and clone farming operation. And I mean, you're building your own commercial nursery at that point, which is really a lot of the commercial nurseries too. This is what they're maybe not cropping them quite that fast, but 1 to 2 months is usually where we're seeing them plumb out, just because you lose performance. And again, all the other facility problems that come with keeping a plant in one spot for that long. It really ruins your ability to properly clean out a room or space.
Super important stuff to keep in mind. Everyone, watch out for your moms. I think we have time to get to one more question. So Seth, what EC of CalMag should we run during the last week of harvest, before harvest?
The last week before harvest? Don't change it. Keep running. As long as you're not high in nitrate, if you've got a late bloom recipe, just ride that out. We're just trying to keep EC in there in your plant. I can't stress this enough. Outside of nitrate, if there is an element in that water that it doesn't want, it's going out the bottom of the pot, into the pot, but not into the roots. So as far as your EC on CalMag, if you're running 3 mils per gallon, keep it at 3 mils per gallon. Typically at this point in the plant's life cycle, it's not quite as calcium hungry, but obviously if that's part of your current mix, keep it in there.
Awesome. Don't switch it up, y'all. And yeah, I know we still have a couple questions over on YouTube. I think that we're going to save those for the next show. We just got a ton of questions this week. So thank everyone for those. So I'll pass it back to you, Kaisha.
Thank you so much, Mandy. I think I have one more that we can address, Seth, if you're up for it. This one came through from Super Cottonmouth. There was a quick question. So when volumetric water content decreases, electrical conductivity goes up typically, right?
If we're in a situation where there is enough salt in the solution to overcome the amount the plant is pulling out of the solution to see that. So I'll go back to that question earlier. If our line we're looking at is 2.1 is our baseline EC, and we want to see that climb, that means the feed we're going to put on has to be in ppm much greater than what the plant's going to take out in ppm. So if we put on a 1,000 ppm feed and the plant uses that up in a day, we're not going to see that line increase. It's going to parallel or go down. If we've stacked up properly to where we have more salt in there than the plant needs, that's when we start to see that inverse reaction where water dries back, salt goes up because the water gets transpired, the salt stays, right? We just have to hit that point where we have enough extra food for the plant in the block that it can't possibly run out of it.
Amazing. Thank you for that overview. We're going to go ahead and wrap it up on this end. Anything you want to address before we sign off, Seth?
Man, I don't think so. I'm just pretty glad winter's over. It's great to see everyone getting out there. All the outdoor stuff's going up. You know, people in California now, they're not having unintentionally cold rooms overnight. All that fun stuff.
You'll be very happy to know I planted my I'm doing 2 plants, Woo. 2 cannabis plants this year, y'all, in my grow bag. So I'll keep you posted if anybody's interested.
Yeah.
I know I am. What are you growing?
Oh my gosh. It's called
tropical?
I think it's called Triple Bling from a good friend of mine who she got them started for me. So thank you, Penny, for those. So excited. I'll keep you all posted.
Nice. Awesome. Awesome.
Amazing. All right. Well, Seth, thank you so much for holding things down solo in the studio this week. Mandy, as always, thank you for co-moderating with me. And thank you to Chris, our producer, for all of the behind the scenes magic. Thank you to everyone for joining us for this week's Arroyo Office Hours. We do this every Thursday. And the best way to get answers from the experts is to join us live. If you're ready to learn more about Arroyo, book a demo on arroyo.io. And one of our experts will tell you all about how it can be used to improve your cultivation production process. Got a topic you'd like us to cover on Office Hours? Post questions anytime in the Arroyo app. Drop your questions in the chat or on our YouTube page. Send us an email at support.arroyo@metergroup.com or DM us on all the socials. We want to hear from you. After the show, we'll send everyone in attendance a link to today's video, and it'll also live on the Arroyo YouTube channel. So be sure to like, subscribe, and share while you're there. See you at the next session. Thanks, everybody. Bye.